Welcome to solverfy.
We want to know if a precipitate will form if 2.7 times 10 to the negative fifth grams of AgNO3 is dissolved in 15 milliliters of 4.0 times 10 to the negative fourth molar K2CrO4. The solid that would form is Ag2CrO4, which, if we write a equation for a saturated solution of this, it would partially dissociate into, we want to know 2 Ag plus and CrO4 2 minus. The KSP of Ag2CrO4, which you can look up in the textbook, is 2.6 times 10 to the negative 12th. And our QSP expression for this is the concentration of Ag plus to the second power, because of this coefficient of 2 in front of Ag plus, multiplied by the concentration of CrO4 2 minus. We want to remember that if the QSP is equal to the KSP, then we'll have a saturated solution with no precipitate formed. If the QSP is greater than the KSP, then we'll have a saturated solution with a precipitate. And if the QSP is less than the KSP, then we'll have an unsaturated solution, meaning we will have no precipitate. Just to quickly explain this, if our QSP is greater than our KSP, that means we have more of these ions here. So by Le Chatelier's principle, our reaction here will shift to the left. If our QSP is less than our KSP, then the opposite happens. We have less of these ions and the reaction shifts to the right. So we'll have less of this solid. If the QSP is equal to the KSP, then our system is in equilibrium, and so we have a saturated solution, but none of this solid will form. So let's do the calculations to see which of these is true in our case. Let's start with finding the concentration for CrO4 2 minus, since it's a little bit simpler. We know we have 4.0 times 10 to the negative fourth molar K2CrO4, which means we have 4.0 times 10 to the negative fourth moles of K2CrO4 for every liter of solution. Then, for every 1 mole of K2CrO4, we have 1 mole of the CrO4 2 minus ion. So that means that we also have 4.0 times 10 to the negative fourth molar CrO4 2 minus. Just to make sure for our units, the moles of K2CrO4 will cancel, and we'll be left with moles of CrO4 2 minus over liters of solution, which is just molarity of CrO4 2 minus. For our concentration of Ag plus, we know we have 2.7 times 10 to the negative fifth grams of AgNO3 in 15 milliliters of solution. First, let's convert our milliliters to liters. There are 1,000 milliliters to every 1 liter. Then we can convert our grams of AgNO3 to moles of AgNO3. And to do this, we need the molar mass of AgNO3. Using a periodic table, we can calculate this to be 169.87 grams for every mole of AgNO3. Then, for every 1 mole of AgNO3, we have 1 mole of Ag+. Checking our units, our grams of AgNO3 cancel, our moles of AgNO3 cancel, and our milliliters of solution cancels, and we're left with moles of Ag+ over liters of solution, which is also equal to molarity of Ag+, which is what we're looking for. Doing the calculations, we get a concentration of 1.1 times 10 to the negative 6th molar. And now that we have our concentrations, we can calculate our QSP. So our QSP is equal to the concentration of Ag+, which is 1.1 times 10 to the negative 6th molar, times the concentration of CrO4 2-, which is 4 times 10 to the negative 4th molar. And this is equal to 4.2 times 10 to the negative 10th. Our KSP is 2.6 times 10 to the negative 12th, so our QSP is greater than our KSP. And that means that we have a saturated solution with a precipitate. So solid Ag2CrO4 was formed.